Hello, Honors Algebra. Mr. Lawrence with your flipped lesson here for Monday, March 26th. I know the date in the corner says the 27th. That's because it's for tomorrow's answer key. All right. Those of you may not know, my first period class is programming the graphing calculators to be able to do the quadratic formula for us. I just don't have time in third period with announcements, etc. My first period class, we have a little extra minutes while we wait on the early birds. Anyway. All right, here is your answer key for the homework that you're working on. Okay. Oops. Looks like I was stationary one place too long. And again, if you think I'm going too fast, all you have to do is pause it. Now look, I'm very proud of many of you. Many of you have been working hard. You're watching the videos. I do want to mention that, just watching the videos might not be enough for some of you. Some of you will need to make sure you're doing extra problems, okay? And you need to know if you're doing extra problems correctly. You can't just passively watch the videos. You've got to be trying the samples I do, asking yourself, well, why did that happen? Not just, like if you make a sign error. If you go like this, if you go, well, -4 plus 8 equals -12. No. And then Mr. Lawrence gives the answer and says, well, it's 4. And then you just scribble it out on your paper and change it to 4. That's not doing the problem. You have to go back and ask yourself, why is -4 plus 8 4? Okay? You've got to make sure you're taking an active role. The class gets more challenging as we go, and my expectations go up. I expect you to retain stuff from chapter to chapter. All right? We're doing the shading. I'm not reteaching it. I expect you to know it already. It's an old concept, and your teachers next year will expect you to do it. Okay. So there's, oops, I'm probably going a touch too fast there. All right. And then there's number 35. I did it by hand because I had a problem with my scanner and couldn't get it to work. And the solution is the green double shaded region. Okay, there we go. So today we are going to talk about some real applications of the quadratic formula, and this is some cool stuff. Let's say, well, first of all, I need to give you this equation. H equals -16 t squared plus or minus v sub o t plus s. Do not let this equation intimidate you. I'll bet every single one of you can tell me that t stands for time. Okay? You can probably make a guess at this as height, and you're correct. I will say it's the ending height. Ending height. Okay? S is going to be the starting height. Okay? And then VO is the what we call initial velocity. It's the initial velocity. Okay? That's all it is. How is this used? Well, let's say you have wheeled out your Gesorcher. You know what a Gesorcher is? It's a giant water balloon launcher. Okay? And you have your Gesorcher. Let me draw my Gesorcher. Hold on a second. There's my Gesorcher over here on the left, loaded with a blue water balloon. And this is your friend's house who happens to like the Kansas Jayhawks, and you want to Gesorch his house right before the big game. But you don't want to do any damage. You just want to put a puddle right before his front door. Right there. And the whole purpose being that when he steps out, his shoes will get wet in the morning, and ha ha ha, won't that be funny? All right. Now, you know that the balloon should travel in a parabolic path. Okay? What I'm telling you is you can use this equation, H equals -16 t squared plus minus v sub o t plus s, to figure out a lot of things. One, you'll be able to figure out how far away the balloon will travel if you know the initial velocity. You can also figure out the time it will take to hit there. Okay? All right, so let's say I tell you that the initial velocity, and we have to know the initial velocity. Let's say the initial velocity and I'm doing this in feet, not in meters. You can tell because I'm using a 16 there. If I was using meters, it's a different number there. All right, I believe it's -4.9 for meters. Initial velocity. let's say it's going at 20 feet per second. Okay, that's fairly fast, 20 feet per second. Okay, and the starting height is going to be the height of the balloon when it's launched. Now, let's say we just do it at 1 foot. Okay, all right, because you pull that gasorcher down and then you launch it up in the air. Okay, so let's say the balloon is 1 foot off the ground when we finally launch it. All right, well, let's see here. Let's see if we can fill in our numbers. We're going to see how long it's going to take before it hits our friend's house. All right, so the ending height is going to be 0, right? H is going to be 0 because we want it to hit the ground. All right, we're assuming that the ground is level and, on the same level as the gasorcher. Okay, negative 16. We don't know t squared. That's what we're going to be solving for. Now, v sub o, I believe, will be positive because we're initially going to hold on 1 second. Okay, so yeah, the initial velocity is going to be positive. And I've lost my marker. Where did I put it? Marker! Oh, marker! Oh, there you are, you naughty marker. All right, very good. So it's going to be 20t. And that, I believe, the starting height is going to be 1. Yeah, because the water balloon is 1 foot off the ground when I first launch it. Okay, now I'm going to run my quadratic equation on it, and I'll do it long ways, but I'm actually going to do all the calculations. I'm going to let the computer do that for me. All right, negative 16, positive 20, positive 1. And I'll do the setup, and it'll be up to you to come up with it. All right, t, I'm solving for t in this case, the time, and I'll get negative 20 plus or minus the square root of 20 squared minus 4 times negative 16 times positive 1, and that'll all be over 2 times negative 16. Okay, now I'm going to have my computer do that. And 1 second. Okay, so here I've got a program on my graphing calculator, which I put in myself. It's going to do the quadratic formula for me. And I know that A is negative 16, and then B is positive 20, and then C is 1. That's my starting height, right? And so the first solution, which really doesn't make any sense, but actually it does make really good sense because you can see that since the parabola isn't starting from the ground, okay, it's going to hit the ground at a negative time if I go to the left, because the parabola is going to look something, where this is the ground, it's going to look something like this, right? And I'm after this point here, but if I extend this backwards, I'm going to be in here where the time is negative. Okay, now in practical application that doesn't mean anything, but it makes sense that it would turn out that way. So I'm not after that solution, but the second solution, hold on 1 second, it is about 1.3 seconds, and that is what I'm after. Okay, so I can come back to, let me see here, I think it's this one. Yeah, t would be approximately equal to 1.3 seconds. Right? So that's how much time it takes for the parabola, or excuse me, for the water balloon to hit the ground. Okay, now that's all we're really doing is we're taking this equation, this one right here, and we're using it. We have to plug our values in right, but then we're using it to tell us how long it'll take something to return to ground. We can also use it, if you think about it, if I have a coordinate system. Okay, and I know that something's been launched from the ground, right, with an initial velocity. I can use it to find out how high it goes, the vertex. This would be the vertex, right? I could also use it to figure out how long it would take to reach a certain height. Like say, this is my height and this is my time down here. How long it took to reach, say, 50 feet in the air. Would it reach 50 feet in the air? Well, that would be here, but then it'll also occur over here because it would hit 50 feet on the way up, and it would also hit 50 feet on the way down. And so notice there would be two different answers for t. All right, we're going to get a little practice with this. The whole point is, can you plug the stuff in? Remember, the equation, one more time, was h equals negative 16 t squared plus v sub o, plus or minus, depending, v sub o t, and then plus s. Okay? All right, I'll tell you what, I'll give you one more problem, and then I'll let you go. Hold on one second. Okay, in this problem, we are launching a model rocket from ground level with an initial velocity of 95 feet per second. With an initial velocity of 95 feet per second. All right, so v sub o is going to be 95 feet per second. Okay. I want to know two things. I want to know how long it will take to reach 114 feet, and I want to know how high it's going to go. All right, so let me see if I can set up my equation, and let's see here. I know that h equals negative 16 t squared plus 95 t plus s. Now, the ending height, or the starting, excuse me, s is the starting height. It's starting from the ground. So I'm going to put plus 0. Now, the ending height for 114 feet is 114. Okay? I can't put 114 in as the starting height because that would mean like I was on some kind of platform 114 feet in the air. It's the ending height. Now, granted, the rocket's not going to end there. It's going to end when it comes back to the ground. But this will help me calculate t. So I'm going to solve for, get it t equals 0, and then I can use my quadratic formula to solve for t. Pardon me. The screen just bounced on me there. So I'm going to get 0 equals negative 16 t squared plus 95 t minus 114. All right. Going to the quadratic formula, I'll leave that up to you. You can go ahead and solve it. I'm going to go ahead and use my calculator. So pause the video. Once you have your answers, you can check in with me. Okay, program. And let's see here. A was negative 16, B was 95, and C was negative 114. All right, and it looks like it's going to hit it at about 1 7/10 seconds. So this rocket is going to go like this, right? And the first time it hits it, it's going to be when the time is 1 7/10 seconds, and that's approximately, and that'll be at 114 feet in the air. Okay, now it's going to hit it again over here somewhere, right, on the way down. All right. And that's going to be about 4.3 seconds, 4 3/10 seconds. Okay, your calculation should have come out to about the same. So about 4.3 seconds. I should label that seconds as well. All right. There you go. There's your two answers. Now, to get the vertex, I'm not going to use the 114. To get the vertex, hold on one second. Okay, here you see I've got a graph using the graphing calculator, and I've solved for the vertex, which the x-coordinate of the vertex is that, okay, just under 3 seconds, and the y-coordinate of the vertex is that. The 2.96875 number, the one that's just a hair under 3 seconds, that is the time that it takes to reach its highest point. This is the highest point that the rocket will fly to. Okay, the maximum altitude. So it's going to go up to 141 feet approximately and then come back down. All right, now if we think about this, let me close this ink layer here. Okay, when we solved on the other paper, where was it? Okay, we got our time of about 1.7 seconds and 4.3. Now remember, those are rounded, so we're not going to get exact answers, but let's type in 1.7 And look at that, we're just a hair above 114. We're at 115 something. Okay, and again, because we used a rounded form, if we go like 1.68, and look at that, we get even closer to 114. So if we typed in the exact answer that the calculator gave us, well, it's not exact, but it's to more decimal points, it's more accurate. We can get the 114 that we wanted. Now the other one was at, where was it? It was at about 4.3 seconds. So let me type in 4.3, and there's that 112, and you know, maybe it was 4.35. Oh no, I'm sorry, I need to go backwards, don't I? It was like 2.8. There we go. And look at that, I'm at 113. If I go 4.295, 112. If I use the exact decimal that we got in our calculations previously, I'll hit the 114 on the nose. All right, so we're going to get some practice with these over the next couple days. I know spring break is coming up. We will have a test on Chapter 10 before break. I'm not sure if it's Thursday or Friday yet. I think I'm leaning towards Thursday in case people are absent on Friday. But if they're absent, maybe they'll just have to watch videos and study over break. All right, Mr. Lawrence signing off. Have a good night, everybody.